As we start with security basics, there are certain security factors that we need to be aware of. We call these the 3 A's, or in fact, there's 4 listed here. It's authorization, it's access control, it's accountability, it's auditing. Those are some basics that we really need to be familiar with. Authorization is just the process of identifying what rights you actually have on a resource. Typically, that's going to be done via permissions, so that kind of gets into our access control. We're determining and assigning privileges to those resources. So the method of authorization is through an access control. It gives us accountability. We're able to determine who to hold responsible for particular activities. We can do that through an auditing or accounting process. So that's just the process of tracking those. So you can see how those security factors are related to one another. The other one that's not here but is inevitable is authentication. In authentication, we are identifying an individual. We're validating that they are who they claim to be, and then they're going to use that identity in order to be authorized to particular resources. And I'm going to monitor to ensure that only authorized users are able to access. You can see how all of these various security factors work together. Another very important concept to understand with network security is the concept of least privilege. With least privilege, it's really part of an overall security strategy in which we only grant individuals the appropriate amount of rights. So for instance, in this scenario, we've got some data entry clerks, and they can perform their job with fewer access privileges. And then we have some financial coordinators, and they need more access privileges. So the goal of least privilege is identifying exactly what you need to perform your job and then just giving you those permissions. We don't want to give you excessive amounts of permissions. If you need administrative rights on a particular server, for instance, I'm not going to give you administrative rights in the domain. If you need the ability to log on to that server through remote desktop, I don't even, in that case, need to make you an administrator. We always want to be conscious of the additional privileges that we might be giving somebody either through permissions or group memberships, and make sure that we're always following this concept of least privilege. Another concept that we definitely want to be aware of is non-repudiation. Non-repudiation is a mechanism that allows us to ensure that the owner or sender of the data remains associated with the data. Now, why would we want to do that? Well, we want to do that because it allows that user, or it prevents that user from disassociating themselves, from saying, I didn't send an email message, I didn't make that change to a document. And so in order for non-repudiation to work, it has to be some sort of independent verification of the sender's identity, but one that remains with the document. Now, the most common method of non-repudiation is something known as a digital signature. Digital signatures can be applied to documents that are being modified. They can be applied to email messages that are going out, and it is a mechanism that identifies the individual that sent it. Now, behind the scenes, there's cryptography going on, and we can get into more detail a little bit later on that. But the concept is making sure that we know the person who claims to have sent this document is the one that sent it, and along with that usually goes the integrity of the data, meaning that the data has not been altered in transit. When we're talking about computer security, we have a few terms that we need to be aware of. Threats is the first term here, and in the realm of computer security, a threat really is any event or action that could lead to the violation of security policy, or an interruption of service, or damage to hardware, damage to facilities. We've got these different threats. Now, threats can actually be unintentional. You could have a user inadvertently make changes to information and overwrite an older document. You could have a user inadvertently bring down a system and cause a denial of service, or they could be intentional. Of course, intentional, a user with the intention of bringing down those systems, either for for a variety of purposes that we'll actually see. So as we look at the information security world or our computer systems, we need to identify the various threats that are against them. And there are some common threats, regardless of a software program, and then there are going to be some additional threats. So, for instance, some are specific to a particular application, like email. One of the threats for email is to bog down the email system with spam, to infect and use a server to send out spam messages to other organizations. That's something that's unique to that application. Whereas damage to hardware, interruption of access, interruption of services, those kinds of things would be common across multiple systems. Beyond threats, we have another term known as vulnerabilities. Vulnerability is really any condition that leaves a system or application open to an attack. The threats are the actual attacks themselves, but threats will exploit vulnerabilities. There are a number of different vulnerabilities. First one here, improperly configured or installed hardware or software. That just means a lot of times when you set up a new router, for instance, it's extremely open right out of the gate. We have no passwords assigned. We have an open Wi-Fi hotspot, and so I have to go in and configure those, get them away from the default settings. Same thing is true for software. We need to configure it. We need to make sure that it is patched. So when we have bugs in software or operating systems that are not patched, those lead to vulnerabilities. In fact, the vast majority of outbreaks in the past have really exploited these vulnerabilities. And sometimes if systems, and this goes back many, many years, but for instance, the SQL blaster worm infected over 100,000 systems. All of those systems, had they gone through the Windows updates and been patched, they would have been protected against the exploit of that vulnerability. So default configurations, bugs in the software operating system, sometimes the misuse of software or communication protocols. We can just have poorly designed networks that allow traffic through network routers or switches that really shouldn't be allowed. That's potentially a danger in relation to security. We could have poor physical security. I should never be able to walk into a server room and access the server. That obviously could lead to a very easy denial of service. Somebody can walk in and unintentionally shut down a server. So that would be poor physical security. Is certainly a vulnerability. Insecure passwords on user accounts, unchecked user input on a website. A lot of times with forms, we need to have some sort of checking going on to make sure that I'm not inputting code directly into a form on a website, because that can cause issues. So those are just a number of different vulnerabilities. Again, the threats are going to be consistent. The vulnerabilities are going to be very particular to the specific hardware or software that I happen to be dealing with. Another term that we need to be familiar with is the attack. An attack is just a technique that's used to exploit a vulnerability. And so I said the threats go to the vulnerabilities, while that the actual action that's being taken is, of course, the attack. And there are many different types of attacks. There's the physical security attack, where I might just steal the hard drive out of a system to access the confidential data that is contained on that. I can boot it up into another non-Windows system and then be able to access that information easier. There are social engineering types of attacks. Social engineering, as we'll see later, is really an attack on people as opposed to computer systems. It exploits the fact that really the weakest link in IT security is the fact that people use the system. And so, again, we'll look at that more later. Software-based attacks, exploiting vulnerabilities in the software, bugs in operating systems, bugs in programs, web application-based attacks that can be inputting wrong information or code directly into forms, trying to crash the web server, cause a denial of service, or even get access to information that I shouldn't be able to see from the web application. And so we have those, and then we've got network-based attacks. Network-based attacks are like denial of service or distributed denial of service, port scans, which often precede the denial of service attacks. All of these, again, are just some of the basic ways in which these vulnerabilities are exploited. Then we have the term of risk. Now, a risk, as it relates to what we've been talking about, is really the likelihood of a vulnerability being exploited. All of these things are interrelated, and so you cannot completely eliminate risk, but you can minimize it. Okay? How do we minimize risk? Well, we can't get rid of threats. The threats are always going to be there. We can address vulnerabilities, and since the threat and an attack is on a vulnerability, well, by addressing the vulnerabilities, then I minimize the risk. So I can put in place protections so that I try to minimize, or the other term that's often used is mitigate, those risks. All right, so there are many different risks. There's system loss, there's power outage, network failures, and physical losses. And I would say that there's also risk associated with some of the things that we have already talked about. There's a risk that an email server is subject, or a web server is subject to a denial of service attack. Why is that risk there, and actually a little bit more for that server than, say, for another internal only server? Well, the reason is because that server is accessible from the internet. Now, it's going through a firewall, so I can take extra steps at the firewall to make sure that only the appropriate traffic is going to that system, but it's a little bit more susceptible. The risk is greater due to the nature of that system. Of course, we've got these other physical risk as well, having to do with the physical system or power sources and whatnot, and we can put mechanisms into place to minimize the likelihood that that risk actually occurs. And so this is all part of a larger security planning, really. When we really get down to identifying and dealing with risk, it's going to be a fairly extensive process because we want to make sure that we cover all our bases and we are protected. We use the term unauthorized access. Most people are going to understand what we mean. If I'm talking about unauthorized access in a store, we're probably talking about somebody going into an employees only area. When I talk about unauthorized access on a network, it's any type of network access that's not approved by the organization, that is actually performed by a user that shouldn't be there. It's unauthorized. Okay, now it could be unintentional, especially from the inside, because we didn't set up access control permissions correctly. A user might be in an area of a web application that they're not supposed to be in, or they might be able to access a data file that they shouldn't have access to. You could also have disgruntled employees that intentionally get in and thwart security systems and have the goal of deleting information or causing problems, or even spoofing information so that it appears that another individual did this, made this modification. Of course, from the outside, it would be deliberate in any sense, where an attacker is trying to thwart firewalls and get into a system and then cause harm. But just unauthorized access in general is just access by an individual who shouldn't be there. Another concept that we need to be familiar with is data theft. Of course, data theft is going to be common, or a common vulnerability that we have. We take steps, put things in place to prevent this. We use mechanisms like encryption and access control, physical security on the machine, but what we're trying to protect against is somebody stealing confidential data. Confidential data is stored sometimes on our client machines, but most certainly on servers, and so when a user is accessing the files on the server, those can be stolen in transit, or they could be stolen from the server system. So in transit, we would have an attacker that's using something known as a packet sniffer or packet analyzer. It's able to capture network packets that are sent from source to destination, and if there's no encryption that's going on, then that information is being sent in plain text. Okay, so we would want to potentially protect ourselves against that. First level of defense from an attacker on the outside is certainly going to be a firewall, but internally for some types of data, we may see authentication and encryption happening so that data can't be stolen in transit. On the server, we're just looking at access controls and physical security. In computer security, there's a couple of terms that get used to identify individuals who might be attempting to break into the system. That's hackers and attackers. Now, they're definitely related to one another, and some people use these terms synonymously. Others do not. I mean, originally a hacker was just a neutral term. This was anybody who was really good at programming, at scripting, at system administration. And so if you were to hack into a system, quote unquote, that just meant that you had the skill and the skill to be able to do that. Okay? But hackers is a term that became associated with illegal or malicious types of intrusions. Attacker has always had that connotation. So now we hear other terms like white hat and black hat hackers. A white hat hacker is somebody who discovers and exposes security flaws in applications, operating systems, network devices, and then identifies those to the manufacturer of those devices or the vendor of that software so that they can fix it. A white hat hacker is one that has a positive intent. In fact, there are organizations now that do penetration testing on networks. They would be considered white hat hackers or ethical hackers. A black hat hacker, on the other hand, is always with malicious intent. And so a black hat is going to be of the attack variety. So just realize when somebody uses the term hacker, especially nowadays, they're not always talking about somebody with malicious intent. Another very basic concept in computer security is the concept of permissions. These are the mechanism by which we determine whether somebody is authorized, most commonly. Authorized access files on a web server, authorized access files on a file server, authorized access a particular area of a database on a SQL server. It's all done via permissions. And so the permissions are going to be on the actual object. It's generally speaking an access control list. So for instance, here we have a folder called marketing, or that contains marketing documents, and we can add users or groups to that access control list and grant them a particular type of access. Okay, so we see there administrators with full access, user one with read only, and the contractors with no access. Now, the contractors may not be on the list, or they could be added to the list and given a deny permission. It just kind of depends on how we want to structure this. Generally, and we'll speak of a Windows network, and on a file server, there is an implicit deny for anybody who's not on the access control list. You must be on the list, either your account or a group that you belong to, in order to gain access. And so typically we don't need explicit deny statements, but sometimes those will come in handy, and we'll discuss why that is. Permissions are always specific to the object. You're granting permissions to this user or this group on that particular object, and it's the mechanism by which we can control what you do. On a Windows network, you typically are using the NTFS file system, and NTFS file system provides the ability to set local permissions. Now, on a Unix Linux system, you're not doing the same thing. There are three types of permissions on Unix and Linux. There's read, write, and execute. The write permission would allow you to create as well as to modify and delete files. Okay, so three basic permissions, and they're granted a little bit differently. NTFS permissions can be granted through the GUI. Every file and folder will have an access control list. When you go to the properties of that file or folder, you will see a security tab. And that security tab is where we would assign these permissions. So as we see there, the permissions can be applied to either folders or to the individual files. If we really got down to it, the file permissions would override the folder permissions, but that's simply because every object has an access control list. So simply because I can get into the folder does not mean that I have access to the files within that folder. Now, generally, when you apply permissions to a folder, inheritance is turned on, and all the files and subfolders within it will inherit those permissions by default. That's there for ease of administration. That is able to be modified if necessary. There are several levels of NTFS permissions. Technically, there are the standard NTFS permissions and the special NTFS permissions. The standard ones are the ones that we generally will use. They allow us to control whether people can read files or run applications, can write to files, can modify or create or delete files, can change permissions. Those are the standard permissions. And then what we'll see is the special or advanced permissions go well beyond what the standard permissions can do. This will be easier when we look at it. But on a Windows network, NTFS permissions are going to be used really across the board to control who can do what with file resources. Another mechanism for controlling security on a Windows network is known as group policy. Group policy is available for Active Directory. Active Directory is the domain services for a Windows network. It's the central component that's always in a Windows network, and an inherent part of that is the group policy. Literally, group policy is configuration management. It means anything I could sit down in front of a computer and do, any area of the system that I can control via the registry or control panel or scripts. I can do all of that in group policy, but I can do it from a central location. And so at a central location, I can create policy objects called GPOs that contain security settings, firewall rules, users and groups, permissions for files and folders, on and on and on, and we can push those out, and they're uniformly applied throughout the environment to users and computers. Now we can set up centralized policies, or we can have decentralized policies, but the level of control here that you have is almost mind-boggling. At the time of Windows Server 2012 and Windows 8, you have over 3,500 settings in a group policy object. I mean, just think about that, and it's hard to imagine something that you cannot do with group policy. And so from a security perspective, group policy is a great way of making sure that you have consistency across systems in a Windows network. Now let's take a quick look at the security permissions that we find on a Windows file server. And now realize here that the permissions that we see in Windows Server 2012 are going to be the same permissions that we would see on Windows Server 2003. And they're going to be the same permissions that we would see on Windows 7 or Windows 8 or Windows Vista. NTFS is NTFS, and it's been the file system of choice really since Windows 2000. Now, the look and the feel might be a little bit different. What we're going to see here is what it would look like on Windows Server 2012 as well as Windows Vista. Okay, so let's say, I'm going to just create a folder here, and it's going to be a test folder for the purposes of permissions, right? We're going to go and create just another folder within there, call this marketing, another folder for research, just get a couple of things, all right? So now let's take a look at the properties. Go to the properties of the test folder. Like I said, you have a security tab. Now on a Windows network, in order to make it accessible, it is going to need to be shared. When we share a folder, we are assigning a name to it, and there are permissions here. Typically, we remove the everyone group because there's some, potential dangers with using that, and I use authenticated users instead, which is still in a sense everybody, but it's everybody who's been validated by a domain controller. And then I usually just give them full control. The reason is because really the share permissions are only applied when you're going over the network. The NTFS permissions are going to be applied over the network as well as locally, and when the two are compared, it's going to be the most restrictive that is going to win. Okay? In other words, I can set share permissions at full control, and then I can go restrict them on NTFS. That's generally the way to do it. All right. So here we have permissions. This is just kind of a read-only list. If you want to modify the permissions, you can hit Edit. Now what we're seeing here are the standard permissions. Full control, modify, read and execute, list folder contents, read, and write. Those are, pretty straightforward. Read permission lets you read. Read and execute lets you run applications. List folder contents is only for a folder. It's kind of like read, only it expands the contents. But, from the folder perspective, it's the same thing. But the thing is that list folder contents is only a folder permission. It's not inherited by files. So if you wanted to allow somebody to open up a folder but not automatically give them read permission, remember inheritance, to all the files in that folder, then that's when you might use list folder contents. Fairly uncommon to use, but it is sometimes used. Write on a folder is the ability to add things to the folder. Write on a file is the ability to edit the file. Modify gives you the ability to delete. Okay. Now notice all of these you have allow or deny, and so we can, we can hit add, we can choose our list of users. I'm just going to hit find so I can see the list of users here. Okay, so we grab, I've just got a bunch of the default things. So I grab a group, hit OK, and then I choose the permissions that group is going to have for this particular folder. We hit OK. All right, now if you hit advanced, you'll see a different view. This is a better look at the access control list. Each entry is an allow or deny. The security principal, which is the user or group, it's really identified by a SID, a different system identifier, but we see the name, the access that they have, whether it's explicit or inherited, and then what it applies to. If you need to do things like modify inheritance, I have to come into the advanced security settings. If I want to assign a permission, say to domain admins, and I want to give them modify, but I only want to apply the permissions to objects or container within this container, or I only want it to apply to files or subfolders. I mean, those odd things can be done, but you always have to get into the advanced permissions in order to be able to do that. Here also is a quick way of determining what access somebody has, because we can go to effective access, we can hit a user account, choose a user. Again, I'm just going to choose our default. Choose a user, add some group members to it, and then view effective access, and then it will list out the permissions that individual has. Okay. So NTFS permissions are really pretty easy to use. I want to do one more thing here. Let's go to marketing, go to properties, security again. Now when I hit advanced here, I'll notice that there are some permissions here that are inherited from the test folder. Now if I disable inheritance, it comes up and asks me what I want to do. I can either remove all inherited permissions or I can convert the inherited permissions to explicit permissions. Okay. Now before I do that, let me click on this and we can say that we want to remove, and it tells me, no, sorry, you can't do that. Right? If I get out of the advanced permissions and hit edit, go to account operators, this is all grayed out. Now you could deny them, but you cannot modify that. So that's the reason that you would need to go in and say disable inheritance, and then I probably want to convert. The reason is there's some system stuff here. System, creator owner. If it's all in all caps, you probably don't want to remove it. So we convert so that none of them are inherited. Why? Because now I can remove. Now I can go in and edit the permissions, and I will be able to change, any of the permissions for that individual. Okay, so you need to block inheritance in some cases when you want the subfolders to not have the same permissions as a parent folder. So that's a quick look at NTFS permissions. It just kind of gives us an idea of what an access control list looks like on a Windows network.